Hello, thank you for watching this video. This video is titled Parallel Lines and Transversals. This is from section 2.2 in our geometry lesson. And the objective of this lesson is to use parallel lines cut by a transversal to solve equations and find angle measures. So let's first go over parallel lines. Parallel lines are simply going to be two lines that do not intersect. And while it's important to know that parallel lines have the exact same slope, if we look at the equation, have the exact same slope, we're not going to be worried or focus too much on the fact that they have the exact same slope. What we're going to do is in this particular lesson is go over, okay, what's the effect of having a set of parallel lines and when we intersect them with a transversal. Now a transversal is simply going to be a line that intersects two or more other lines, and it doesn't necessarily have to be a set of parallel lines. They don't have to be parallel. These other two lines could be something else. They could also be intersecting themselves. But for this lesson, we're going to focus on when they are in fact parallel. So let's look at the first thing we're going to look at is what happens to the two parallel lines, which are P and Q here, and they're cut by the transversal T. So T for transversal. What we end up creating again is two sets of four angles. We have these four angles on line P and the transversal, and then we have these four angles again created with line Q and again with this transversal. The first thing we're going to focus there on of these 8 angles is going to be the consecutive interior angles. Consecutive interior angles are angles that have the exact same are on the same side, not the same shape, but the same side of the transversal. So for example, 4 and 5 are considered to be interior because they are inside the parallel lines of P and Q. And because they're on the same side, that's considered to be again consecutive interior. So angle number 4 and angle number 5 are consecutive interior angles, just like angle number 3 and angle number 6. Those are also considered to be consecutive interior angles. Now, what's unique about consecutive interior angles is that they're supplementary. Meaning that if you add up those consecutive interior angles, they're going to equal to 180 degrees. So adding angle 4 with angle 5 is equal to 180, just like adding angle 3 with angle 6 is going to equal to 180. Now the second thing we're going to discuss when we cut again a set of parallel lines by transversal are corresponding angles. Those are angles that are on the same side of the transversal and in the same spot. So again, if we focus on considering what's on the inside, okay, so here everything here is considered on the inside and these points being on the outside. Another way of defining this or thinking about corresponding angles is when we're looking at angles that are on the same side of the transversal, but one angle is on the inside and the other angle is on the outside, or outside and inside, like angles 1 and 5. 1 and 5 are on the same side of the transversal, but notice how angle number 1 is on the outside and angle number 5 is on the inside. So those things are corresponding. Now what's important about knowing about corresponding angles is that they are congruent. Any set of corresponding angles is going to be congruent. So for example, since angle number 1 and angle number 5 are corresponding angles, that means that they're equal to each other. So angle 1 is equal to angle 5. If I look below angle number 1, which is angle 4, well, the corresponding angle to angle 4 is going to be angle 8. And again, notice how angle 4 is on the inside between P and Q, and angle 8 is on the outside. And since they're both on the same side of the transversal, they're both on the left of the transversal, and one on the inside and one on the outside, then that's what another way of thinking about corresponding. So angle 4 and angle 8. And again, using this definition, angles are on the same side of the transversal and the same spots. You can consider that. If we look at this angle right here, out of the 4 angles, angle number 4 is on the bottom left-hand side of the transversal. Angle number 8 is in the exact same location, bottom left-hand side of the transversal. So that's another way, another perspective of thinking about what the corresponding angles are. So if I look, angle number 2 is on the top right-hand side of the transversal. So among the parallel line of P, along P, it's on the top side of the line, and it's also on the right side of the transversal. So that corresponds to 6. It's on the top of the parallel line and also on the right. So angles 2 and 6 are corresponding, and then so is 3 and 7. Angle 3 and angle 7. Those are corresponding angles. Now linear pairs, that definition doesn't change. Linear pair is going to be a set of adjacents, again, next to each other, two adjacent angles that add up to 180 degrees. So in this example, we have several sets of adjacent angles. We have angles 1 and 4, angles 1 and 2, angles 2 and 3, and then angles 4 and 3. Those are all sets of or linear pairs. Anything that is part of a straight line. 1 and 4 are part of this straight line, just like 2 and 3 are. And then 1 and 2 are part of this straight line, just like 3 and 4. So angles 1 and angle 2, angle 1 and angle 4, angle 2 and angle 3, and then angle 4 and angle 3. And then the same thing again down here. These two angles, 5 and 8, 6 and 7, 3 and 6, and then 8 and 7. All examples of linear pairs. Now the next one are vertical angles. Again, those are going to be the angles that are on opposite sides of each other, or that are across from each other. And vertical angles, just like in the last lesson, are always congruent. So that would be angle 1 and angle 3. Notice again that they're opposite of each other, so they're going to be equal to each other. 4 and 2 are opposites of each other, so they are also congruent. They're vertical from each other. So angle 4 and angle 2. And the same thing is true down here in the bottom sets. Angle 5 is opposite of angle 7, so those are congruent. And angle 8 is congruent with angle 6. 6. There you go. Oh, there I go. So those are opposites of each other, and again, they're going to be congruent. The next set of angles that we're going to discuss here are the alternate interior angles. Now, alternate interior angles are going to be the interior angles that are non-adjacent, and in other words, are on opposite sides of the transversal. So here you need to rely on understanding what is considered to be on the outside and on the inside. So the outside is going to be the angles that are not in between the two parallel lines. So interior refers to in between the two parallel lines. So let's start by understanding interior. That means between the parallel lines. And the alternate part of it refers being on the opposite sides of this transversal. So in this case, the interior angles are 4 and 3, 5 and 6. And the alternate interior angles would be example 4 and example 6. Notice again they're both in between the parallel lines, but they're on opposite sides of the transversal. 4 is on the left, 6 is on the right. And what's important about alternate interior angles is that they are congruent. As you can see, notice that this angle here is an adjacent angle, and so is angle 6. Angle 6 is also an adjacent angle, and it just so happens to be the exact same adjacent angle. So those are going to be equal to each other. So angle 4 is equal to angle 6. And then the other set of alternate interior angles is going to be angle 3 and angle 5. And those two are also going to be equal to each other. Now, alternate exterior angles is just the opposite. Well, kind of the opposite. When I mean opposite is that they are not going to be in between the set of parallel lines. So let's start with that. The word exterior here means they're on the outside, okay, or better yet, above or below the parallel lines. So for example, those would be angles 1 and 2. Those are above this parallel line, and angles 7 and 8. 7 and 8 is below the bottom parallel line. So they're going to be above or below the parallel lines. And again, alternate, same thing. One's going to be on the left of the transversal, and the other one's going to be on the right side of the transversal. So look right here. Here's my transversal. The angles on the left are 1 and 8, and the angles on the right are 2 and 7. Well, also the other ones, 3 and 6, are also on the left, but we don't care about those because right now we're looking for alternate exterior angles. And just like alternate interior angles, these things are going to be congruent. So since angle number 1 is on the left side of the transversal and on the above this parallel line, that's going to be congruent to the angle 7, which is on below, on the outside of Q. And again, notice again how angle 1 is an obtuse angle and how angle 7 is also an obtuse angle. And it just so happens that they are up the exact same obtuse angle. So angle 1 is equal to angle 7, and angle 2 is equal to angle 8. So what technically what happens here is that when we have a set of parallel lines and we cut them or intersect them with a transversal, we end up creating these exact same 8 angles. The same 4 angles that are above here are the exact same 4 angles that are down there. And when we cut a line into, again, 2 pieces, or divide a straight line into 2 pieces, or separate into 2 pieces, the same 2 angles that we create here, the obtuse and the acute angle that we create right there, that linear pair there, are the exact same sets of linear pairs among the other ones. And even left and right, they're all the exact same set of linear pairs. So if we know that this is equal to 60 degrees and this is equal to 120, 120 because that's obtuse, and 60 degrees, then we know that we're creating the exact same set of obtuse and adjacent angles. It's going to be the exact same numbers every single time. Now, the way that we use this information is to set up equations and solve for values of x. So, for example, here, classifying the angle pairs. So, classifying the angle pairs, we can figure out what the angle measurements are by looking again at what the relationship between the two angles are. So as you see right here, notice that we have this acute angle here and we have the exact same acute angle here. The relationship between these, if we cut this in half, if we cut this into two, not half because they're not equal, we can see that we have the 64 on the left side of the transversal and this question mark, the one that we're looking for, on the right side. So they're alternating angles. Now, are they alternating interior angles or alternating exterior angles? Well, to determine that, again, look where those angles are. Notice that they're not in between the parallel lines, so they are exterior angles. So this is an example of alternate exterior angles. And if this angle appears 64, then that means that this angle is the exact same acute angle. So it's also going to be 64 degrees. Now let's look at the next one. So notice again where the inside is. So the highlighted yellow is the inside and the other one's going to be on the outside. My transversal is here, and notice that my two angles are on the same side of the transversal, so they're not going to be alternating. They're on the same side. They're both on the right side of my transversal, so not alternating angle. And because they're not next to each other, they're not going to be a linear pair. Seeing that one angle is on the outside and the other angle is on the inside, this is an example of corresponding. Another way to determine again what corresponding is that notice again that we have this obtuse angle and this angle up here, if we just focus on these four angles right there, is on the top right hand side among these four angles here. And if we look at the bottom angles, again, the four bottom angles that were created, notice that this one is also on the top right hand side. So that's what corresponding means. They're in the same location among the four angles that are created. So if you label them as A, B, C, and D instead of letters, and label the bottom ones the same thing, A, B, C, and D, notice that they're both located in position B. So they're corresponding angles. And the significance of corresponding angles is again that they're equal to each other. And you could kind of see that just by looking at the angle. Notice that this angle is obtuse. Notice that this angle is obtuse. And well, it so happens that they're the exact same obtuse angle. So they're both equal to 106. Now for the last example, again, I'm going to highlight the interior. And notice that both of these angles are on the inside. We have 108 and we have this bottom angle right there. Now notice that they're also on the same side of the transversal. So here's the transversal and they're both on the right side, just like in the second example, on the right side of the transversal. Now, since both of them are on the inside, they're not corresponding and they're not alternate interior angles. So they're not alternating and they're not corresponding. To be corresponding, one of them has to be on the outside and the other one has to be on the inside, like this example there. But since they're both on the inside, they're not going to be corresponding. And if we pay very close attention, notice that this angle is an obtuse angle while this angle here is an acute angle. So the relationship between these is that they're going to be an example of a linear pair. Well, kind of, because linear pairs mean that they're next to each other. And these again are not next to each other. They are same side interior. They're again interior angles. Well, same sided interior angles. which means again they're consecutive interior angles. So it's consecutive interior angles, again angles that are both on the same side and on the inside, add up to 180 degrees. So these are consecutive interior angles. So that means that 108 plus this angle there, we'll just put a question mark. You know what, let's just use the letter X, has to add up to 180 degrees. And because we have an obtuse angle and acute angle, again, that's an easier way of thinking about it. Well, this obtuse angle and this acute angle have to some way pair up somewhere, either be on top of each other or be left and right of each other, which if we look at the corresponding value, that would be up here. That would be the corresponding point to that one on the top right hand corner among these four angles. The top right hand corner among these four angles is this one right there. So we can consider this to be X, and we could also think about this as, oh look, we have a linear pair, so they're going to add up to 180 degrees. So the way we're going to figure this out is by subtracting that 108. So 72. So the value of that missing angle, which I'm going to label as X, is equal to 102. Let's look at some more examples of that. So we look at this example here. Notice that 48 and the question mark, let's call it X, are both on the inside, so they're interior angles. Now unlike number 3, which were there on the same side of that interior angle, that would make them consecutive interior angles. But since this one, they are on opposite sides of the transversal, the 48 is on the left side of this orange line and the X is on the right side of that orange line. They're alternate interior angles, and they're congruent. So our X is also going to be 48, and you can kind of see that by looking at the type of angle we have. The 48 is an adjacent angle, as you see right there, and if we pay attention to this angle, you can see that this is also an adjacent angle, and it so happens to be the exact same adjacent angle as that. Now number 5, you should be very familiar with that. These are examples of angles that are opposites of each other. So they're vertical angles and they're congruent. So X is going to also be 133 degrees. And our last example, again, you should be familiar with that. These two angles are part of a pair, adjacent pair, that are part of a straight line. So they're linear pairs. So X plus 58 has to add up to 180. So when I subtract 58 from both sides, I end up with 127. So X is equal to 127. Degrees. Now we can apply this even to algebra. We can then set up our angles to represent some algebraic expression and use it to set up equations that are going to be either equal to each other or add up to 180 degrees. Here we're not going to worry about classifying and try and identify really what the correct name for is, but we can kind of just use our brain here, use again our geometric spacing and verify and look that we have the following. Notice that this top angle right here is an obtuse angle, and this angle right here is the exact same obtuse angle. Now, since both angles are obtuse, they happen to be the exact same obtuse angle, so I know that they're going to equal to each other. And even though, again, I said not to really focus on the name or the relationship between these two angles, they are alternate interior angles. Which is why they look like, that's why exactly why they're both obtuse. They're both obtuse because of that, because they're alternate interior angles. So setting them equal to each other, we can then figure out the value of x. So using the same technique we've been using all semester long, keeping our numbers to the left, our letters to the left, and our numbers to the right, we're gonna subtract 14 from both sides, subtract the 5, and we're gonna end up with 1x is equal to 7. Well, we divide by 1, and x is going to equal to 7. For number 8. Well, for number 8, again, before I classify it, again, look, pay attention to this. Notice how this angle is an acute angle right here. And notice that the 138 is an obtuse angle. Well, since the top one is acute and this one is obtuse, they're not going to equal to each other. So the only other option is that they're going to be supplementary. They're going to add up to 180 degrees. So adding these two, getting 131, let me write the top one first, 24x plus 1, and adding it with 131, that's going to equal to 180 degrees. So adding these two together equals to that. So let's do that. Let me simplify this part right here. So let's simplify this. Before we start doing letters to the left and numbers to the right, let's simplify this by adding these two quantities right there. Adding the 1 and the 131. So that's going to equal to 132. So 24x plus 132 is equal to 180. So subtracting, moving this to the other side makes it a 132. So 24x is equal to 48. Dividing the 48 by 24, we get that x is equal to 2. And there's my solution. And again, the reason that they are supplementary is because of the angle relationship. Now, since they're both on this inside, notice that they're both inside and on the same side of the transversal, they are interior angles. But since they're on the same side of the transversal, they are consecutive interior angles, which means that they are supplementary. Which you can figure out again by just simply looking at the type of angles that they are. One being acute and this bottom one being obtuse means that they have to add up to 180. They're not going to be equal to each other. Now here, in order to decide again whether they're congruent or whether they're supplementary, look at the angles. If they're both the same type of angle, both obtuse or both acute, they're equal to each other. But if one of them is different, if one of them is acute but the other one's obtuse, then they're going to be supplementary. So here, notice that this angle is obtuse, this angle is also obtuse, so they are equal to each other. So 16x plus 4 is equal to 15x plus 8. Plus 10, sorry, that's a 10. Now, the mathematical way of determining, again, or the geometrical explanation for this, okay, the geometry rule explaining this idea is that these angles are they're corresponding angles. I was going to say alternate, but no, they're not alternate because they're both on the same side of the transversal. Notice that they're on the same side of the transversal. They're both on the left side, so they're not alternating. And notice that one of them is on the outside of the parallel lines. Here's a set of parallel lines. I've highlighted them in yellow. And the inside is what I've highlighted in yellow. Notice that the 15x plus 10 is on the inside, but the 16x plus 4 is on the outside. So this again is the corresponding situation. Another way to determine that they're corresponding is by looking at the placement of each angle. If again, since we end up creating 4 angles up here using this line and the transversal, 1, 2, 3, 4, this angle is on the top left hand side among the 4 angles. Notice that this angle is in the same place. It is on the top left hand side right here in this place right there. So they're corresponding because they're located in the exact same place, relative again to that transversal, relative to again when the parallel lines are cut by the transversal. Well, let's go back into now solving the equation, since this is what we want. So we would move the letters to the left, the numbers to the right. Negative 15, negative 4. 1x is equal to 6. And dividing by 1, x is equal to 6. On this example, again, even if you cannot recognize and identify that these are vertical angles, the main concern from this point is trying to determine, okay, should I be adding these two things up and equaling to 180, or should they equal to each other and solve the equation for x that way? Well, the way you're going to determine that again is by look at the angle. Notice that this angle is an obtuse angle. So 3 plus 17x is an obtuse angle. Notice that 16 plus 9 is also an obtuse angle. So even if you can determine that they're vertical, which means that they're congruent, you can determine that they're congruent by looking at the angle size. Since this is obtuse and this is also obtuse, then that means that they have to be the exact same obtuse angle, so they're equal to each other. So 3 plus 17x is equal to 16x plus 9. Now, doing the same technique as before, letters to the left and numbers to the right. Put it up there. Let me do this way. Letters to the left and numbers to the right. We're going to get negative 16x, negative 3, and 1x is equal to 6. So x is equal to 6. Because we're going to divide by 1. So x is going to equal to 6. For example number 10, this is an example of linear pairs. We have a set of linear pair. Notice that they're both on the inside, but they're not on opposite sides of the transversal. Let me get highlighter. So yes, they're both on the inside, but they are not on opposite sides of the transversal, so they're not alternating. So they're not alternate interiors, nothing like that. They are adjacent because they're next to each other. They're next to each other, so they're adjacent and part of a straight line. So linear pairs. So again, what does that mean? It means that they're supplementary. Now again, if you cannot determine that they're linear pairs or alternate interiors, anything like that, the key idea from this point on is understanding, are they going to be supplementary or are they going to be congruent? Are they going to equal to each other, or are they going to be added together to equal to 180? Well, in order to determine that, just simply look at the angles. Since this angle is an acute angle, and this angle is an obtuse angle, they're not equal to each other. So the only other option is that they're supplementary. So like I said, if you cannot determine how the angles are related to each other, alternate interior, corresponding, alternate exterior, linear pairs, vertical, consecutive interiors, any of that, I want you again to simply look at the angles themselves, and you should be able to determine, like I said, whether they're going to add up to 180 or they're going to equal to each other. And in this case, because they're different angles, different angle sizes, acute and obtuse, they're supplementary. So you need to add these up and equal them to 180. So to add this up, you add up the x's together. So 1x plus 1x, that's 2x. Let me write it first. Let me write it up here. So we have 60 plus x plus 134, and by adding that, that's going to be set to 180. So before we do the whole letters to the left and numbers to the right, I'm going to begin by first again simplifying this side and combining again my like terms. So I can add the x's together, which is going to be 2x. I can add the constants together, these two, and that's going to equal to 194, and that equals to 180 degrees. So minus 194 we get that 2x is equal to negative 14, and we divide that by 2, so x is equal to negative 7. And the last example, the inside is what's in yellow, and both of these angles are on the outside, so they're not interior, they're exteriors. And because both angles are on opposite sides of this transversal, they are alternating, so they're alternating angles, and since they're both on the outside, they're exterior angles, alternate exterior angles, which means again that they are congruent. Now again, if you were not able to identify their alternate exterior angles, you should be able to identify that they're congruent, however, by just simply looking at the angle. Notice how this angle is an acute angle, and this angle up here is also an acute angle, which means that they're the exact same acute angle, so they have to equal to each other. So 23x plus 1 is equal to 24x minus 2. So if I do the same thing as usual, letters to the left, numbers to the right, we get negative 24x, negative 1, and negative 1x is equal to negative 3. We're going to divide that negative 3 by negative 1, and x is going to equal to positive 3. And there's your result. That concludes this lesson on parallel lines cut through a transversal and how we use it to find the angle measurements and how to set up equations so we can figure out the value of x or solve an equation using again those angles, the corresponding angles, alternate interior, exterior, consecutive interiors, the verticals, angles, the linear pair aspect of this, to set up the equations again and solve. I hope this was helpful, and again, thank you for watching and enjoy the rest of your day.